our topic for today, we'll be looking at matrices. Can everybody see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Our topic for today is matrices. I don't know if you would have heard about matrices before. Probably some of you would have done it before, right? But for today, we'll be looking at the definition of matrix, the order of the matrix, some operations. Y'all still hear me?
Yes, sir.
Yeah.
Yeah, so for matrices, we'll be looking at some definition, the order of the matrix, the order of the matrix, operations dealing with matrices. And by me saying operations, I mean addition, subtraction, and multiplication. You'll notice that I did not say division because we do not divide in terms of matrix. So it's basically addition, subtraction, and multiplication. As we go along, you'll notice that we have two types of multiplication that is done with matrices. So all here, we'll also be looking at the adjoint of a matrix as well as the determinant of a matrix. We'll be looking at singular and non-singular matrix as well. So as the screen pops up, I need you to take the information. You'll be given like roughly a minute, 30 seconds to get the information. Our first screen states that a matrix is a rectangular array of numbers. And if you look at the examples that we have there, you'll see I have 2, 5, 7, 12, 4, 7, 19, 0, 5, 2, negative 6, 3, 10, and negative 7. All of these formations that you have there, you should be able to draw a rectangle around it.
Yes, sir.
Yes, sir.
You have the information for the definition of a matrix?
Yes, sir.
Yes, sir.
Good. Moving on. So we have now the order of matrices. Now you'll notice I have some of the writing in black and some of the writing in blue. The blue represents the order of each matrix above there. So matrices are named or ordered according to the rows and columns. Are we good there?
Yes, sir.
Are we good there, folks?
Yes, sir.
Yes,
Good.
sir.
Now, for the first one, where we have 2 and 6, that matrix is known as a 1 by 2 matrix, simply because it has one row of numbers going across and 2 rows of numbers coming downward. You have 1 and negative 6, that's 2 rows and 1 column.
Sir.
You have 0, negative 3, 7, that would be a 1 by 3 matrix. You have 1, 9, and 12, that is a 3 by 1 matrix. Anybody not clear in terms of the order of the matrix for the rows and the column?
Yes, sir.
I asked if anybody's not clear.
Can you please repeat it with the numbers, sir? Thank you very much.
I didn't hear you.
Can you please repeat it about the numbers? You said something about the numbers and the rows and the columns.
Yes. Okay. If you look at the last matrix, 3 by 3, right? That 3 by 3 matrix there is telling you that you have 3 rows and 3 columns.
Oh, okay.
Right? Yeah, you have 3 rows and 3 columns. Now, if you can see here, this is the rows. That is 1 row, 2 row, 3 rows. Everybody following?
Yes, sir. Yes, sir.
Good. Now for our columns, we have 1 column, 2 column, 3 column. That is how come we get a 3 by 3 matrix. Okay? For the first example where I have 1 by 2, I have 1 row of numbers straight across, and I have 2 rows downwards. Everybody on board now in terms of rows and columns?
Yes, sir. Yes, sir.
Good. Please take down the examples. Let's move on. But mostly for matrix, you'll be mostly using the 2 by 2 matrix, which is this one here. So most of the work we'll be doing will be done with the 2 by 2 matrix. We have the information. Do we have the information?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
But moving on. Anybody didn't get the information? Speak now. Good. Next one we have here is order of the matrix. Operations with matrix. The first operation we'll be looking at is addition of matrix. You can check out the example. We have given the matrices A, 3, -2, 0, 8, -4, -7, 10, 15. And I have C, 3, 0, -4, 19, 7, 8. The first matrix we define is A plus B. Please take a look at matrix A plus B. You'll notice that just as the operation is given, A being the first matrix, B being the second matrix, that is how it's set down. You will also notice that I have some colors within the matrix. Can anybody tell me what the colors signify? Or what does it mean? Why did I put the colors? Anyone there?
Yeah.
Yeah.
But I'm asking a question in terms of addition of matrices. You'll notice that I have 3, -4, and then I have -1. If you can hear me, in terms of addition and subtraction, the colors mean that we added the numbers that are in the same position for each matrix. So you'll notice that the 3 is the first element of the first row, or you can see the first column. It's added to -4, which is the first element of the second matrix, the first element in the first row or the first column for the second matrix, and that would give you so this value is added to this value and give you this value. You'll notice that the position remains the same. First element added with the first element will give you the first element. You check out, look at 8. This will be 8 plus 15. This is supposed to be 15. This is supposed to be 23. Okay?
All right.
Yeah.
But now the same rules for the addition, the same rules would apply for the subtraction. What is also important for you guys to remember is the order in which the matrix comes. For example, the first question tells you A plus B. So we start with matrix A. Yeah, we start with matrix A plus matrix B.
Okay.
Okay?
Yeah.
You have the example?
Just now.
In a second, sir.
Repeat?
Almost finished.
I didn't get that.
Almost finished. Comment.
Everybody here? Okay, okay.
Yeah.
Everybody got the example?
Yes, sir.
Good. So that was A plus B. But look at these examples here. Yes, you have B plus A, you have A minus B, you have B minus A. What do you notice about A plus B and B plus A?
Is the same answer at the end?
Huh?
Yeah, the answer at the
Get
end.
back the same answer, which means that in terms of addition, addition for matrices is commutative. Please make that note. Addition for matrices are commutative. It means that whichever one goes to the front, whichever one goes to the back, whichever one goes to the middle, once you add it, you will get back the same answer. That was a question on last year's multiple choice paper. What do you notice with the subtraction?
In the first one, the answer ends with like a -10 and a -7, but in the second one is not negative. That's what I see.
Okay, you'll notice that for the subtraction, the answers, they become the inverse of each other. When I say inverse, I mean opposite in terms of sign. So for A minus B, you have a +7, +5, -10, -7. And for B minus A, You have a -7, -5, +10, +7. So can we say that the subtraction in matrices is commutative also? Is that so?
No.
No, sir.
No, it is not, because we did not get back the same answer. Even though we got back the same, we can say the same numbers, the same digit. It's not the same
We
value.
did not get back the same sign.
We did not get back the same sign, exactly. Right, so whilst addition is commutative, the subtraction is non-commutative. Please take down the examples.